Today I want to show you how I went about solving problem number 6, ERC20 Vault exploit, found here on the Solidity Challenges repo. So in order to get started, simply clone the repo and open it up in your preferred editor. Over here on the ERC20 Vault README, it states that this ERC20 Vault is a trusted vault that has just added support for a new ERC20 token WETH. My grandma is about to deposit her life savings of WETH into the vault. Can you hack the contract and report the bug to the vault owners? Save my grandma's WETH by proving there is a bug in the vault contract. All right. So we just need to prove that there's a bug. We don't have to run an attack contract. Moving over to ERC20 Vault. So this one here, this was a very interesting one. So bear with me as we go through it. You can see that they import an interface to give it permit logic. The token itself is WETH, and we have our token right here. So the WETH token, it is at ERC20 and has additional functionality. It has a deposit and a withdrawal. So that token then is set up in the constructor. The vault itself has 3 methods: deposit, deposit with permit, and withdraw. So let's start with deposit. Anybody can deposit, and they can deposit any amount, and a transfer from will happen as long as you've already approved the tokens beforehand and your balance will be updated. Pretty straightforward. The withdraw, same thing, anybody can call it with any amount. It will then update the balance and transfer the tokens. You will notice it's not really checking whether or not you have that balance, but one could say that because we are using a version of Solidity 8 or greater, that the compiler will pick this up if we underflow. Nonetheless, that's not really the focus point here. The focus point actually becomes the deposit with permit. So this allows us to, in a single transaction, approve and allow for the approval and transfer of funds. They've implemented the permit as such with a single line of code. Anybody who's worked with permit knows it's a little more steppy than that. Actually, it's very steppy. And just to give you an example, I did a little mock of what this contract would look like if they properly implemented a permit function. So right here from the top, you can see there's a lot to go through. I'll go through it super fast. We would import the interface. We're going to use it with the safe ERC20. That's optional. And then you have to define the EIP720 type hash. There's the domain separator storage. There's nonce tracking, of course. And then in the constructor, you would do some initialization of the domain separator, where this creates a unique domain separator following that EIP712 standard. Furthermore, there's the permit function implementation, where you would do some basic validation. We need to rebuild the permit digest. This recreates the message that was signed by the owner. Then we have to create the final digest, where we pass that using EC recover, doing signature verification. Then and only then can we execute a permit and transfer. So that line that you saw lives right here. So yeah, if you're seeing just a single line of code, nothing else, permit, there's definitely something wrong with the implementation of this permit. All right, all that to be said, there's even more that needs to be disclosed here. So this permit, it's coming from the token contract, but you will have remembered that the token contract itself doesn't even have, well, maybe you don't remember, maybe you overlooked it, but when I went through this, told you it has additional functionality, it has deposit, it has withdrawal, but I don't see permit anywhere. So they're calling a method on this contract that doesn't even exist. So what happens when we do such things? Well, in this case, we do have a fallback function, so that will be triggered, which triggers our deposit. And our deposit here is actually going to run a mint of all things. So it's going to take in our vault address and it's going to pass in our value. We didn't pass any value, so that'll be 0. It's going to mint 0 tokens and emit an event. That's very interesting. So in this function, the very first thing is this permit does everything I just said, mints 0 tokens to us, meaning that this is pretty much meaningless. So knowing that this is meaningless, we're left with 2 other lines of code. It runs a transfer and updates the balance. Well, that's pretty identical to what happened up here in the deposit, but with one key difference. Can you spot it? All right. The key difference being the balance, when it gets updated here in deposit, we're actually using message.sender. Here, we're not using that. We're using a recipient that's passed in as a parameter. So we have the ability to actually pass our own address if we wanted to. and the amount as well. You can see we can pass the amount. So I would say that this is going to be the vulnerability, and this is what we're going to exploit. So in order to do that, let's move over to exploit vault.t.sol. I'll start from the top here. I didn't create an attack contract like I've done in past videos. I did everything right here in the test suite. Top to bottom, you can see they have the ETH contract, they have the vault. They established 2 EOAs, victim and attacker, and they give an initial deposit amount of 5 Ether. They deploy the WETH contract, and they deploy the vault, passing in its address. Then they deal some funds. So the victim and the attacker both get funds, and then they pass those over to the WETH contract. The victim has 10 Ether, where us, the attacker, we will have 1 Ether. Next, it looks like they are running an approval. This is actually a key point right here. So that approval I talked about, where over on the vault, if you run transfer from, it will not work if you don't have an approval in front of it. So the approval is being given here, where they are on the WETH contract, the vault address here. Again, this is the victim. Victim's been pranked here. So the victim is given the vault the approval to transfer as many tokens, unlimited amount of tokens, right? And then they call deposit. And the deposit amount that the victim puts in is 5. So we're trying to steal 5 Ether. All right, all the logic happens here. You can see my code has been added right here. They start by giving us a starting balance so we can see what it is. They prank us so we have the context to run. And this is what I did. I literally prepped the parameters, and I ran deposit with permit. So the owner is the victim, and here's the recipient. I just put my address in here, and the amount that I want is I want that whole deposit amount, that grandma just added. So with everything else being meaningless, I just zeroed it all out because we know it doesn't work. And then we ran it. And by running it, we'll just go through it one more time. We ran it. This recipient is me. The amount is 5. Permit, it might as well be commented right out. We have an approval. The vault, that is, has an approval to transfer unlimited tokens. Or actually not even the vault, sorry, the token contract here, the WETH contract here has that approval. So it says, oh, I'm approved to transfer. Let's go ahead and do it. So from the owner, so from grandma, let's transfer it over to this vault. That's fine for the amount of 5. That's all fine. But here is where we get what we want. We as the attacker, they've transferred it to the vault, but they've updated our balance. So the attacker now has an amount of 5. Perfect. Now that we have 5 Ether sitting in our balance, we can simply call withdraw. And the withdraw does a transfer over to us. That gives us our 5. And the final assertion being that the WETH balance of the attacker is 5 plus the 1 that we started with here in the test suite, so 6. And it has to equal the deposit amount. Again, 5 plus deposit amount was 5 plus the starting balance was 1. So our starting balance is 1 because we see here, it's just defined that our balance before we did the attack was just 1. So that is my attack here. Let's see it in action. We'll just jump over to the terminal here. I've already preloaded the command. Okay, so from the top, you can see test steal funds from vault. That's the name of our test suite. And we started with a balance of 1 right here. We were then pranked as the attacker. We called deposit with permit. And the key factors here being we passed in our attacker address and the amount. With that, we called permit. Permit did absolutely nothing. It did run a mint. That's why you see a transfer event and a deposit event. It then called that transfer from. Remember, we had the approval was already given to the WETH contract. So it called transfer from, transferring from the victim to the vault, 5 Ether. It performed its transfer. And then the withdraw from the vault. So we withdrawed 5. And that allowed the WETH contract to transfer to the attacker, that being us, obviously, 5 ETH. At the very end, we just got our balance. Our balance was 6. And finally, that assertion indeed did pass. So that was my approach to solving the ERC20 Vault exploit. If you had a different way of doing it, I'd love to hear it. Or if you want to talk about my approach, feel free to contact me. My contact information can be found in the details below. See you in the next one.